So I want to share my Geiger counter conversion slash repair. So I had a broken Geiger counter board, and I kind of told myself way back in the day, like, if I can get the sync fixed, I'm going to convert it to digital. So this is the good board next to the bad board. The bad board's on the right. So they're Victorine Model 493s, classic analog Geiger counters. Fortunately, they have circuit diagrams, so it was relatively easy to diagnose the problem. So what I did was I voltage mapped and referenced good versus bad. And then I got to play with my antique oscilloscope, which is a lot of fun because I've never actually really had a real reason to use it. So it's really interesting to see like different waveforms, as like capacitors discharge and stuff like that, which like I've never seen in person because I'm mechanical, not like electrical or something. But I thought it was really cool because this is a tube-powered CRT tube. And my check source that I was using is radium dial. Stuff is crazy radioactive. So inevitably it was one of the BJTs, one of the transistors, Q1, that was actually bad. So it's a picture of the replaced transistor. And here is sort of like what the Geiger counter should sound like the analog version. That's the good Geiger counter. As you can probably tell, the even for such a small amount of radium, just that little dot is radium that the pencil is next to. So very radioactive, but good for trouble sourcing things because it's. Anyway, so I eventually got to a point where I was like, well, what's the solution? And I thought Arduino Uno with an I2C display. So this is my first sort of like prototype. This was just like the beeper section of it. And this is the code. The first part, it's just your basic input variables, and I use Boolean variables as well in this. So not a whole lot. And of course, this is just your setup. Now, one thing to note is that there's an interrupt here, and that is to switch basically like display modes on the display. So this is the real meat of the program, I guess you could call it. So it's a nested if loop or if statement within a while loop. So basically the while loop allows you to, how should I put this? You want to know what the mode at which Geiger counter is measured is based on counts per minute. So you want to know the duration of, or the frequency of counts coming in. So what I do is I have an interval of 10 counts, and I say how long does it take for every 10 counts? And then I can extrapolate what my CPM is from that. And then inside that, basically it's really simple. So I'm using the output from the Geiger counter, the audio output, as basically a trigger for a uniform output pulse or click or tick or whatever you want to call it. And this is really important because if you just amplify the output, then you're going to get different sounds, because basically analog Geiger counters, the gain works by increasing or decreasing pulse duration, because it's all analog, and you have like a dial that is basically measuring voltage and current, really. And so the more current, or the more significant that each click is, the more significant the measurement is. So this was kind of like the prototyping board I started to build onto. So just single MOSFET end channel amplifier. And this is kind of me hooking up to the Geiger counter, so you can kind of see there. So nothing too fancy, and I'm running on a 9-volt battery, which is kind of out of shot there. And then we've got some anatomy here. So, if you want to pause the video and look over this is basically just the simplistic view of everything. So like the MOSFET, the display, the resistors, that sort of thing. And of course the breadboard, because, I haven't finished the assembly on this thing yet, basically. So two things to note. One, the Geiger counter, actually, its ground is positive, so things work a little bit differently. So again, I would pause this section just to kind of read over this. But basically, like, I have a 1 mega ohm resistor between the two terminals of the Geiger counter to sort of keep like an antenna effect from happening. So this is the diagram. Talk a little bit more about it. So you'll notice that there's a 1 kilo ohm resistor between VCC and the input pin 7. And what that does is it holds the pin high. And so this is, normally a detection would be something like when a pin reads high. But in this case, because ground is positive on the Geiger counter, it's when the pin goes low. So you want it to be high all the time until the pulse happens. And when the pulse actually happens out of the Geiger counter, instead of pulling it high, it pulls it low. And that activates the trigger. So not anything real crazy. So again, a single N-channel MOSFET attached to a buzzer and VCC to generate the output pulse. And in the script, if you look at it again, there is like a section where you can modify the pulse duration, or excuse me, the beep duration, and you can change the sound of that. And we'll actually see that in just a second, because you'll see two variations. The first time I did it with just the audio section, and then the second time where I actually have the display attached as well, and the beeps sound different. And then I also have, in that first clip, I have it compared to the analog Geiger counter, what it sounds like again, just so you can have a kind of side-by-side reference. So there's the digital pulse, there's the analog pulse, and then of course this is once I actually have the screen on. And again, the beeps do sound different in this sense because I changed the sort of like the beep duration in the programming. So, and you can notice here that I have an I2C display, and the reason I did this is because I wanted simplicity. I didn't want to have like 6 wires coming off of it. I just wanted 4 easy wires to the system. I included the I2C library, not a problem. And then of course the really cool thing is that the interrupt here, you'll see in a second, is it actually switches between the measurements. So this one's counts per minute, and this one is microsieverts per hour. And of course, you can never have too many Geiger counters. So I hope you enjoyed this. This is actually what I wanted to do for my senior controls project, but unfortunately, I was really time constrained, so it didn't end up happening. So I instead made a stepper motor driver, which was a lot of fun and cool as well. But this is something I've wanted to do for a really long time, so I'm glad I could get it done.